Alright everyone, so welcome back to my channel. So today we're gonna do a problem called longest duplicate substring. You are given a string, consider all duplicate string, substring of s that occur two or more times. The occurs may be overlap. Return any duplicate string that has the longest possible length. If s does not have duplicate substring, the answer is empty string, right? So basically you just need to find the longest. Let's say in this first example right here, you have the string as banana. So the A and A right here. Say I will write that, right? So and this string right here, they are the longest duplicate, and also say the here, right? Technically A right here and N right here, they are also a duplicate substring, but they are not a longest duplicate substring, right? So the first thing that may come to your mind is banana is the using sliding window to find a substring, because there's substring, so you use sliding window. But that technique is not gonna work, because if you try to do sliding window, right, you expand the window, and using the right pointer right here is moving, but there is no way when to shrink the window, right? So you just don't know. Let's say I am at this point right here, B, I go to A again, I go to an A, right? But there's no case, no such evidence or anything that in this problem saying that when we have to shrink our window. So the sliding window will not gonna work in this case. Another way to do this problem is you have to convert this problem to a different type of problem. So the way to do that is we're gonna do binary search on the length. So let's say the string right here, the substring it will have, the smallest substring is 1, right? It's gonna be 1, or we can just, smallest substring in here is 0. An empty string is 0. And the biggest substring is gonna be the whole string. So it's the length of the string minus 1. So this is the range that we need to use, right, to do the binary search on this. Then when we use the binary search in this range, right, we find a middle in here. We need to ask ourselves that, hey, is this middle length, right? We have the length at the middle, let's say arbitrarily 4. We have to ask ourselves that, is there any duplicate substring that have size of 4? So the problem begin more easily to do. You just basically need to find substring that have the right length 4. You just need to you need to slide this for window, and this one and over one. You need to slide that window, and you put that into a set and any kind of set in here, and then you just return true, right? If you found it in the set. Since this, let's say if this 4 is true, right? We have to, if this 4 is true, it means that there is a duplicate and we want to be greedy. So we shift our lower end to this side right here, because we want to search the upper bounds of the range right here. Let's do a quick dry run and we're gonna see what happened. A and A and A, right? So the smallest one is 0, right? And the largest one is 3, 4, 4, 5, 6, 7, 2, 0, 1, 2, 3, 4, 5. Oh, actually it's only 5, right? So we also have this. Our midpoint 2. So this is our midpoint. So we have to ask ourselves, okay, of 2, right? Is there any wood side of mid? So we have to ask ourselves that if the duplicate substring with a length of m, we gonna slide a window of length of 2 right here, because m right now is 2. We slide that window. We have BA. We add our BA to our set right here, right? And then we move on. We take this part AN. We have AN, and we move again to the next part. We have NA right here, and then we move to another part AN. We have AN right here, so we return true, right? Since we return true, our result is currently, and we also need to, we not just return regular true, we also return true, right? So we return true right here, but not just true, we also need to return the C of this. No, we need to return the string that return true, right? So this is NA, so we return NA right here back to this one to keep our condition. And then since we have is return true, it means what we have to update our result as NA, right? Then we also need to be greedy, so we move our left pointer to this side, and we do again binary search on this one, 5 or 8. So the midpoint is 4. To move this, midpoint is now 4, right? And now we have to do all of this again one more time. This one is now 4, and we have to slide a window that have size of 4, right? Slide of 4. So we add banana in here in the set, and then we add the next part is A and we also need to add this part and A, and then that is the end of the loop. So we don't have anything, we return 4 and the empty string, right? We don't have to update our result, but we need to move our right pointer to the midpoint. So our right and left pointer right now is right here at 3, and then do it again, and then eventually the 3 is work because there we have A and A right here, so it's gonna return A, and we just need to update our result with that. So let's jump right into the code, and then we see what we're gonna do. So I do have the low and high right here. I have 0, I have the length of the string 1, and I also have my result initially at empty string. So I just do a quick binary search right here. So I have the y of low rather than high, right? So I have mid right here. It's going to be equal to low plus high divided by 2, right? So I will have my is duplicate. This one is when I call the function, when I call my helper function. So I also have a helper function right here called have duplicate, right? And I pass my k in, right? So in here, just gonna put the if duplicate else for and the empty string, right? So I will have a duplicate right here and the substring, and then I will have to call the have duplicate, right? And I pass my mid in here, so I will have this duplicate and my substring. If there is a duplicate, mean that I have to be greedy. I want the longest. I will have to move my lower pointer. It's called upper bound, so we call mid plus 1, right? Result. And I also need to update my result because it's a valid result from a half duplicate. So I will just update that, right? And then else the other case we just do high equal mid minus 1, and then in the end we just return our result. Now we put all of our focus on the half duplicate right here. So we have to slide window of k, right? So usually sliding window. So we have a scene set right, and we just do a quick for loop. So for I in range of the length s, right, and minus k plus 1. So we only need to loop from 0 to the point that have a length of k, right? So our current string right here is gonna be s of I to I plus k. This is our current string. We check if our current string is in scene. If it's in scene, we return true, right? And our current string. And then in the I will also need to add a string to the scene, right? And then I will need to return for right here, right? So this should work. Let me see. So it's work on this case. Let's see if it's work on here. I don't think so. Oh, it also work. So however, so quite easy hard problem, but that is work. However, we can do it a little bit better because this one time complexity, right? The time complexity. Okay, for time complexity for this problem, the binary search right here will have the log of the length of the string, so log of n, right? The sliding window will cause n time complexity, so we'll have n times log n. However, we have the slicing in here, right? This sliding string will cause the have the k in there, right? and we also have to have the scene. Basically this string we have to the string of the scene, since when two string compare with each other is cost length of that string. So this is the another k, right? So it's 2k, and the memory complexity is O of n. However, whenever you add the substring right here, it is actually O of n k right here. So basically the memory will cost a lot if you use the string right here and you add the string into the set. There is an optimize using a technique called rolling hash. So I should not write like that, but rolling hash, right? So basically what we need to do in here is we need to be a little bit more complicated. So what we need to do is, because we have 26 character, right? You think of the base character 257, right? So this is base 10. You can think of it like a character, but this is base 10. So the two off, like a string, to take off the 2 right here, you need to take this, you need to own the number, right? Take like in here and then multiply with 2, then take this number and subtract this, so we can get the 574. That is when we chop off the head, right? When we chop off the head, we have like 74 right here. But to add the number, let's say we remove 2, and when we want to add 2 at the end, right, we have to multiply with the base, which is 10 plus 2 at the end. So we multiply 10 is 740 and plus 2 at the end, so this one is 2, so it's 5742, something like that. In base 10, that is the formula. You can get this number. It is actually really simple. So this is 4, right? This is the length of 4. Think of it like this problem. You have k side window and you have to slide that k side window. K, for example, k right now is 4. That you have to take the base, which is 10, right? Multiply with the 10, and then you only need to time it 3 times. 10, right? So 10. Yep, you time it 3 times. So it's actually base 10 power of k, right? K right now is 4 minus 1. So this is the formula to get the number to chop off the head, right? So this number multiply to, so it's to get this number right here. So that is the formula. So this is base 10, but for string, it just simply change to base 26. But for this case, I use base 31 because the prime number, right? This is prime. It's helped to make sure that there's no collision. So this is no collision in here. It means that when you do base 31, it is a really large number. Let's say 31 over 10 right here is extremely large. So this 31, we need to mod it by power of 9 plus 7. So you mod, right? But when you mod this number, it's gonna somehow being converted to same value. So to avoid this, we use the 31. That is one way to avoid it because it's a prime number. To avoid this is you manually check if you found the same hash. But I will explain that in code, so we will know that. So let's get back to the code right here. We have a duplicate. I'll keep everything in here. So I have a base as 31, right? I have the mod as 9 plus 7, right? I also have the character bounty, and I return the ordinary of a. This is just to get the number value of the character. So in here, instead of the regular set, I will have a count dictionary. So it will be a default dict of a list. So this list will be the hash as a key to the list of indices, right? So yep, and then I have our current hash, which is our current window. Maybe I will name it a current window, equal to 0. And I also have my just call it multi, which is the power of my base k minus 1, and the mod right here. This is the one that I mentioned before, the multiply used to chop the head up, right? And then in here I will need to process my window. So for I in range k, right? So my current window right here would be equal to current window. No, put it in the parenthesis, multiply with the base and plus the character of the string s I right here, right? And then I have to mod it by the mod. So this is our current window with the size of k. Do that, then I'll add that to my dictionary, right? So current window, right? So append 0, and then I will have a for loop right here for I in range of starting with k, then the length s right here. So I have the character out and character in, right? So character out would be the val character of the string in the head, so I minus k, and character in would be the string at the moment, so at I right here. So now I will perform the chop head, right, formula that I mentioned before. So my current window will be equal to current window minus the c out, right, multiply with the multi right here, right? And then I also have to mod it. Then I will perform the add, right, add to the end of the current window. So current window equal to current window multiply with the base. Basically it's the same like this. Oh, so this one should be c out. Oh, bad. Oh, I already called c in. Yeah, c in. And I also have to mod this by the mod, right? So that's at the end. So right now I will have my starting index is gonna be I minus k plus 1. This is the starting index from my current window, right? My current window, because we chop our head, right? And the index at the character out plus 1. So this is the index, and this is where you can find it. And if the current window, right, is in the dictionary, we have to, in here we can do the return string at the bottom right here. But first we need to get our current string here, start index, right? Oops, keep happening. Index plus 1, right? Oh no, not like this, but right, start index plus k, and then we just return the current. We can do that, but as I mentioned about the collision, right, this is should be I plus 1, so I plus 1 right here, because start index plus k then plus 1, that's same thing. But the of collision, the current window might appear in the dictionary, however the mod it return like a window can have the same hash. So since that case might happen, we have to do a formally check. So for index, and that's why we use the dictionary with some index, so we can manually check that. So in index of current dictionary of the current hash window, right? So we have a bunch of, have a same hash. If our current string, this is where we have to, the only where we have to manually check every single string. So index plus the index plus k, yeah, case. And if that is true, if this is true, we return in there. Right, so we return, and we could return the current string. Yeah, after all of this, we have to update our dictionary, right? And then we return false if in other case. And then that is, I think, all of it. Let's try it. Oh, syntax, because this, oops, there is an error, and let's try to see why. Okay, you know what happened? I returned it right here. The end is not correct, so it should be like this. Let's try it again. Network error. Oh, now it should work, and it should probably work the same, and it's a little bit faster. See, so it's right here before it's right here. So using this is a tiny bit faster, and that's it. So hope you like the solutions, and hope to see you soon on the next video. All right, so